Okay, so I'd like you to find this problem, inverse testing homework 4, page 121 of your packet, and I'd like you to read through this and identify again the type of data, hypothesis test or confidence interval, and what kind of statistics they give you. Okay, and take a look at the table that they give you, try to make sense of what's given there. And then I would hit pause on the video until you're done. Okay, so now this is a kind of tricky one. This is quantitative in nature. They asked them to rank their depression level on a scale of 1 to 20 or something like that. We don't know exactly what the levels are, but that's a numerical value. That's assigned, so it's quantitative, even though 0.5 probably doesn't make sense. They're using whole numbers here. It is an hypothesis test, again, because I can't find the word confidence interval in here. And if you look here, there's no data given to us. I don't see anything, data, any kind of averages or anything. However, I do know that I would be looking for X bar, sorry, and S, but I don't see them anywhere here. Next thing you also need to note here is that this is, it looks like a 2-sample test. So if you take a look at the data, you see the depression level with the caffeine, depression level with the placebo. So it looks like a 2-sample test. However, one of the key differences here is it's the same subject doing the experiment twice. So if you read through this carefully, they have to do this twice, once with caffeine, once with placebo, and they compare their depression levels. Okay, well, this is what we call a matched pairs test. This, for all intents and purposes, looks like a 2-sample test, but in reality, it is a 1-sample test in disguise, because your subjects are doing the same thing twice, and that's the key to understanding a matched pairs versus what we saw last week, a 2-sample test. A 2-sample test, you're going to have 2 different subjects doing the experiment and comparing the results. In a matched pair test, you're going to have the same subject do the experiment twice and compare the results. So that's what we call matched pairs. And the big key here is to notice that we're looking at the difference. We're comparing subject 1 caffeine depression level with caffeine to the depression level with the placebo. And we're looking at this column right here, and this is the important one that we're going to pay attention to as we go on in this problem. So what we want to do is realize that a matched pairs test is a special case of a 1-sample test. So we are going to, because this is quantitative, we're going to run a t-test. Remember, t is for quantitative, z is for categorical. Since this is quantitative, we're going to run a t-test. It's just a fancy 1-sample test. So we're going to go through the state plan, do, and conclude for a test that involves a matched pair test. Okay, so here's the state. Just set up so you can see this. And in this case, if there's no difference between taking caffeine pills and placebo, then the difference, this last column, should be equal to 0. Okay, if there's no difference, then we should get a value of 0 here, because the depression level with the placebo or the depression and the caffeine should be exactly the same. So when you subtract them, the mu diff, which we call, is equal to 0. If there is an increase in depression level, then the mu diff would be greater than 0, meaning that the difference between basically the depression level between caffeine and the placebo would be positive, would be greater than 0. So this is the only difference here. We're going to use mu diff, and will always be equal to 0 when it's a matched pairs. And then mu diff will be either less than, greater than, or not equal to, depending on the situation. And in this problem, we want it to be greater than 0 because we want to show that there's an increase in depression level. Okay, so here's my state. And there's my alpha level, 0.05. Okay, again, it's not given to us, so this is the one that we always use, 0.045. So then we go into the plan, and we do random, normal, and independent. Again, with a 2-sample test, we had to show that both samples are random, that both samples are normal, and that both samples are independent. But because this is still technically a 1-sample test, it's just a 1-sample test in disguise, we have to still only do one. Okay, random assignment. I've noticed here, they were either randomly assigned to take the caffeine first and the placebo second, or vice versa, took the placebo first and the caffeine second. So random assignment was given. Now, in order to get the normal, because if you notice, this is quantitative, and if you remember the central limit theorem, we need a number of 30 to say it's normal. Unfortunately, our sample size here is only 11. So what we got to do is make our own graphs and tables. So I'm going to show you how to do that on the calculator. So if you come back here, you can take a look. I've put the data in here. However, even though it's all in here, subject, this is depression with caffeine, this is depression without caffeine, this is the difference. The only one we really care about is the difference column, because that's what we're doing our data on. We're comparing the results, and we're looking at that difference column. So I'm going to make a graph of the difference column. So I'm going to click to add variable, and you get all those choices, but I only put the difference column. So I'll be honest with you, in practice, if you had to do a problem like this in the AP exam, you would only put the difference column in the calculator. You wouldn't put any of the other columns in there, because they don't help you out at all. You would just put that difference column in there, okay? But I just wanted to show you that if all the data were entered in there, ignore the other three and work with the difference column. And this is how you get the graph. If you choose to use a dot plot, or you can use a box plot, either one of those would be a good graph. And basically what you're looking for is if there's no obvious outliers. The box plot's the best to do that there's no outliers here, but you can actually see that with the dot plot here too, and see there's nothing really that kind of extends itself away, significantly away from the others. But like if you're not sure about 18 and 19, the box plot would confirm that, because you can look here and say, hey, there's no outliers here. The tail goes all the way out to 19. So that's the big thing that we're looking for, and we would sketch either one of these graphs in there. You can see I sketched both of them. You would sketch one or the other, the box plot or the dot plot. Okay, and again, you would say there's no apparent outliers, so it would be approximately normal. So the box plot's probably the best graph to be able to do that kind of information with. Independent. This is the first time we've seen this. These are volunteers, if you notice. So what we got to do here is with volunteers is we just got to show that one person's results should not influence another person's results. And that should be easy to see here. One person's depression level should not affect somebody else's depression level if these people are not working together, they're working at different jobs, etc. Okay? All right, so those are the three sections, random, normal, and independent, and how it works. A couple things that are different here. A reminder, this is a matched pairs test. So it's a one sample test in disguise. And we had to make graphs here. So we actually had to put the data into the calculator and make graphs. Now, on this year's AP exam, I don't expect you to have to do that, but in case you're in that process, you need to do that. Okay, so again, three formulas: words, symbols, and numbers. So the words, remember, is in your formula sheet, stat minus parameter or standard deviation. Formula, again, it's on your formula sheet. And then here is the numbers. Now, I'll show you on the calculator where I got the numbers from. When I did here, let me clear this out so you don't see this. To get this, you would go to menu. I did a calculator page, by the way. I would go to menu, statistics, stat tests. And remember, this is a one sample t-test in disguise. So I'm going to do t-test. And the difference here is that I actually have the data stored in a list and spreadsheet. So I'm going to use the data version instead of the stats, where they gave me the mean and standard deviation. I don't know what they are. So I've got to go and find those. So I'm going to put in here the mu that is associated with the null hypothesis. That 0 means the null hypothesis. So if you go back and take a look at what you wrote here, mu difference in this case is 0. So our null hypothesis is going to be 0. Our list is going to be, remember, it's the difference column. So we're going to have all four of those in there, but we're only going to pick the difference column. The frequency list will always be 1, so just leave that. And just want to make sure we pick the right arrow. Remember, we wanted greater than here. Then we hit OK, and there is the t statistic and the p-value. And notice here, this is where the mean and standard deviation is, which I'm going to use when I go to the numbers. So the mean is 7.36, the standard deviation is 6.92. There's my t statistic, there's my p-value. So I'm going to need all four of these values to record here. So when I come back here, you can see here, there's the test, there's the mean, 7.36, minus my mean from the null hypothesis was 0, over the standard deviation, which was 6.92, over the square root of 11. And that's how it comes out, 3.53. and my p-value is very, very small, as you can see there. I also want to record the degrees of freedom, which again, the calculator gives that to me. I go back to that. Degrees of freedom is 10. So you can see there, and n is 11. All the numbers I need, the calculator will give me. And degrees of freedom is 10. So remember, when we go to the do for a quantitative data, we need to record the t-statistic, the p-value, and one additional information, degrees of freedom. So this would tell us, if we had to use the table, what row we would look at. So remember, it's always n minus 1. So our sample size in this case is 11. Minus 1 gives me 10. So that's where that number comes from. So then we do the final thing to conclude. We compare this p-value, which is very small, to our alpha level, which we just stated up there in the state, and we would reject the null, which means there is a difference between taking caffeine pills and a placebo in terms of increasing the depression level. Okay, since this is very, very small, means we get to reject the null, which is a fancy way of saying the null is probably false, which means if the null is false, the alternative is probably true. Okay? So take a look at this problem, take some notes, make sure you got this, and I'm going to assign some problems that are similar to this.